what we want to do, we've got an experiment where we're going to react blue. I hope, excuse me, I've crossed through the red because we only got one group, so I think we'll just go with the blue. Blue number one. So this is the starting point. We have a K, and then the concentration of blue number one, that's food coloring. And how does it react with sodium hypochlorite, bleach? Okay, so this will be N, this will be M. And the end result, what we want for the end result is to find out what this is and what these two are. All right, and then when we write up the rate law, it's going to be rate equals some value times blue number one to the something times sodium hypochlorite to the something. That's where we're headed for this experiment. All right. The problem is we can't let both of them vary. We gotta somehow we gotta make one of them constant so that we can assess the order of the other one. And the way we do that is we increase this concentration so high that it essentially doesn't change. And then we look at this one as if it were a single reactant. Okay. So the way we do that is we combine this one and this one into a single term and write a new rate law, an intermediate rate law, on the way to our final answer. So we'll call this one K prime. And it's just that one times that one. Then we have blue number one to the N. Now we can work with that. But we need to do two experiments. The reason being that we're talking about it's like the initial rates where you have we're not going to use three experiments, which we would do if we were doing initial rates. We're going to keep it simpler than that. We're going to run this experiment at one concentration of sodium hypochlorite, and then we're going to cut that concentration in half, which is still pretty large, and run it again. Okay, so we'll actually get 2 K primes out of this one, out of one experiment versus the second experiment. All right, and we'll come back to those calculations. Let's do the pre-labs first. Okay, number one, a container of household bleach has 5% sodium hypochlorite by weight on its label. So the, let's see, bleach concentration on the label is 5%. Weight. If the density of the bleach is 1.08 grams per density of the bleach equals 1.08 grams per milliliter. What's the molarity of this solution? We need to know the molarity of the solution because we're eventually going to work this out as in molar terms. But we're going to use, instead of molarity for the blue dye, we're going to use absorbance units. Okay, so it's only good for those units. Right? If we were to actually use molarity here, we get a different value for K. But it's more convenient to use absorbance units because we can stick our reaction vessel in the spectrophotometer and watch the absorbance units decrease over time. Okay, so how do we find out the molarity here? Well, molarity has to be moles per liter. And this is grams per 100 grams. So that's where we're starting. 5 grams of sodium hypochlorite per 100 grams of solution. Okay, we need to change this to volume, right? Because eventually we're going to need liters in the bottom. So we got to change that to volume, and that's where density comes in. That's our conversion factor. We're going to do one at a time. Remember, when you have multiple units to be converted, just do one at a time. So we're going to do the bottom one first. We got grams on the top, right? Milliliters on the bottom. That puts milliliters down here. So we have 1.08 grams per milliliter. That cancels grams and leaves us with milliliters, but we need liters. So let's say milliliters on top, liters on the bottom. 1 liter is 1,000 milliliters. Okay, so there we got liters on the bottom. Now we got to convert this to moles. Okay, and we know how to do that. When you see that, you think molar mass. So what's the molar mass of sodium hypochlorite? 23 for sodium. Oxygen is 16. And chlorine is 35, 45. 5, 4, 14, 7, 8, 84.45. No, 74. 65. 2, 4, yeah, 74. 74.45. Okay, that's 74.45 grams per mole. And now we've got moles per liter. That gives us our molar concentration of 5% sodium hypochlorite. Okay, so the rest is just crunching numbers. Let's see. I got 0.725 molar sodium hypochlorite. 5% used to be the standard concentration of bleach off the shelf. Now, there for a while they went up to 6 and then 6.5, and now I think they're 7 and 8%. So you have to read the label before you use bleach. I think our bleach that we're going to use is 6%. So this was how you would calculate the molarity of your bleach. And then when you dilute it, you just apply your dilution factor. All right. So that answers number 1. Let's see, number 2. I'll leave that up there for now until I need the space. How many grams per liter of sodium chloride are required in order to prepare a solution with a concentration equivalent to the solution in 1? So why do we even need to do that? Why do we need a sodium chloride solution that's the same molarity as this? Because when we take full strength that we're going to use here and dilute it, you don't want to dilute it with water, right? That throws off the ionic balance. Here we have in solution, we have sodium ions and hypochlorite ions in solution. If you want to balance that molarity with sodium chloride, you need sodium and chloride ions. This will decolorize the blue dye. This will not, but it will maintain the ionic balance because you've got the same number of sodium ions and the same number of anions. Okay, so we need our diluent to be composed of sodium chloride. But we got to make the solution, right? If we want our sodium chloride solution to be 0.725 725 molar sodium chloride. Then we need, let's see, that's moles per liter. Moles per liter. How many grams per liter? So we're going to have a liter of solution, and we just need to know if we're going to have a liter of solution, then we just need to know how many grams that is. 0.725. So we can leave the liters alone and just change moles to grams. So sodium chloride would just be missing the oxygen, wouldn't it? Eight and 58.45. So 42.4 grams of sodium chloride per liter. That will give you the same concentration, molar concentration, as the bleach. Now, I'm not going to make up a liter of that. Make up at most 250 milliliters, which would be 1/4 of a liter, right? So 1/4 of that would go in 250 milliliters and give me plenty to last for several years. Okay, that's number two. Three. Let's see. Let me read it. What is the percent sodium hypochlorite by weight for a liter of bleach that is 0.8 molar sodium chloride? Sodium hypochlorite has a density of 1.09. That's just going backwards. That calculation goes backwards from this one. We're told the molarity to begin with is 0.8 moles of sodium hypochlorite per liter. And we want mass percent, or grams of sodium hypochlorite per 100 grams of solution. So let's change the moles first, because we've got our conversion factor right there. This is 74.45 grams per mole. Okay, gets rid of moles. Now we got grams. That's grams of sodium hypochlorite. Now we need per 100 grams of solution. Well, I don't want to take any shortcuts, so let's just do this. Let's change it to milliliters first. Here we go. Milliliters first. And then let's apply the density. Okay, so grams, milliliters on top, and grams, and this is of the solution. This is not of, this is grams of sodium hypochlorite. I don't want to get those confused. All right, so this is 1.09, wasn't it? 1.09. There we go, per milliliter. And then we multiply by 100 to give us percent, because this is fractional grams of sodium hypochlorite per gram of solution times 100, like any percent calculation. So 0.8 and 74.45, 1,000 and 1.09 and 100. So that's 5.46%. Weight. Excuse me. Is that all of them? I think that was it. Yeah. Okay. So you just need to study the procedure. Have your notebook set up to receive the data. You're going to need two tables. Right? One for collecting the absorbance over time for the full strength bleach, one for the half strength bleach. And then I included an explanation at the back, didn't I? Yeah, calculations. So when you get to these last pages, this one gives you a sample calculation for determining what the concentration of bleach is in your full strength. And then the half strength, you just divide it by 2. So let me see if the procedure does what I think it's going to do. Every 10 seconds, yeah, okay. How many drops of sodium hypochlorite? Okay, that determines how many drops you need. First step is to find out how many drops to decolorize the dye within 2 minutes, is it? 3 minutes. So you want it to decolorize in 3 minutes. But then you want to isolate that dropper, because that dropper is the one you're going to use through the entire experiment. And those droppers are not calibrated. So when you put 10 drops in something, you want to be able to take that 10 drops, take that sodium hypochlorite solution over to the balance, and how much does that weigh? Or you could do 50 drops and say, how much per drop? Then we can go from there. Since we know the mass, then we can go through this procedure and find out what the molarity of your bleach actually is in the reaction.